We're gonna get started in like 2 or 3 minutes. We're just waiting on some other teachers. All right, I'll wait another 3 minutes and then we'll get started. All right, just one more minute.
May I ask a quick question, just in case? I'm a parent though.
That's okay.
It's July 4th, there is no classes, right? And for whatever, yeah, okay, just want to double check. So whatever, so even though we didn't get any message that, I don't know where to check, but yeah, just want to confirm there is no class.
I'm not actually sure about that. You can go contact the the manager about that.
Mhm.
If you want me to, I can send you his email and stuff.
Okay. Okay.
So yeah, I'm actually not sure. Supposedly there shouldn't be class, but I would double check on that.
Well, thank you so much. And also, like July 3rd, I want to know if they hold class on that day. So, yeah, could you send me through chat? Can you tell me the email so I can email them?
All right.
Mhm.
All right, how about I do that at the end of class or
Okay.
somewhere
Oh,
in
yeah,
a
we
rest?
gotta start. Yeah, sure. Thank you
Okay,
so
all
much.
right. All right, cool.
Mhm.
All right, so I'm gonna start sharing my screen now. And let me know if you guys can't see it or something hasn't loaded in. So yeah. All right, so welcome to AMC 8 training info session. So today we'll just be dedicated to AMC 8, talking about the AMC 8 curriculum and all that. And a bit of background from me. I'm a rising senior at High Technology High School, and I've had a decent history with competition mathematics, having done math counts and AMC 8. And in high school, I've competed in AMC 10 and AMC 12, and am a 3-time AME qualifier. So here are just my background. And today we're just going to be covering the content of the course, the general goals of the course, as well as how how the structure of the class is and some general tips. And we'll leave, let's say 10 minutes at the end for any questions that you guys may have. All right. So the goal of this is to spread the mission of Team Teach Kids to mathematics. So this is the first time that IGO Learning has done something with mathematics. So the goal is to basically spread this idea of teens and obviously higher education to higher education students to teach mathematics. And the goal of this course is to teach the foundations of mathematical thinking as a high school or college student or beyond. And that's the goal of this course. And obviously, the other goal is to prepare children and teens for prestigious math competitions, such as the AMC and also math counts as well, and other competitions. And these will be of great use in the future for college and beyond. So once again, to reiterate, we're creating a problem-solving foundation for success, and the goal is for the students to aim high and score high. All right, so the general content of this course, this applies to both AMC and AMC 10, is it's very problem-solving oriented. So this is different from other classes that IGO Learning holds, which is it's more theory and knowledge-based. This will be more focused around problems, meaning you're gonna be assumed that you have sort of a basic understanding of the concepts ahead of time. And you'll basically honing your knowledge through doing problems. And for the AMC 8 course, we'll be using problems from past AMC 8 contests and other related contests of similar difficulty. And once again, to reiterate, it is problem solving centered. And we're going to be covering 4 areas of mathematics: algebra, number theory, geometry, and counting and probability. So these are the 4 areas that are tested on AMC 8 and AMC 10, but to various degrees of difficulty. So yeah, it's basically applying these contests will use elementary mathematics, like the 4 areas that I listed, meaning no calculus is involved, but to a degree where the problems require quite deep and thinking. One second. All right, so moving on to the curriculum. AMC 8 and AMC 10 will follow very similar content and curriculum. So as of now, it will be 16 classes focused on the 4 areas of problem solving strategies. Obviously, this is to change, but as of now, the general structure is 16 classes and 16 classes, 1-hour classes. So every single class will cover a specific part of like the overarching areas of mathematics. For example, we might have 5 classes on algebra. One class might discuss sequences and series. Another class might discuss just general foundational algebra for the rest of the course, and so on. And the same applies to number theory, geometry, and counting and probability. Okay. Oops. So yeah, they follow AMC and AMC 10. They'll follow similar curriculum and content, but there is a difference, which is AMC has a special emphasis on algebra and reasoning, which is kind of like the foundation for the other areas of mathematics. And while AMC 10 will have a more spread out emphasis, meaning there will be roughly much more evenly distributed emphasis on number theory, geometry, and counting and probability. And AMC 10 will cover the concepts more in depth, and the problems will be much more challenging than for AMC 8. So that's the difference, but overall, the general structure is the same for both classes. All right, at any point, let me know if you guys have any questions about the content, or if I'm going too fast with the slideshow. And if you want, then let me know in the chat if you want me to share the slideshow later for you guys to take a look at. All right, so for teaching, these are some rough prerequisites. Obviously, you don't need to have those, but it's very recommended. So high school student and beyond, proficient in mathematics with a familiarity with AMC 8 and AMC 10, meaning the concepts in them and also their difficulty. So you have a good understanding of what is covered on the AMC 8 and AMC 10. And in school, it is very recommended that you have taken mathematics to at least algebra 2, and you must have taken geometry and algebra 1, because both cover geometry to an extent. And we're particularly interested in high scores in AMC. So AMC 8, 16 plus scores and AME qualifiers. However, you do not need that. For example, if you have higher education in mathematics, that is fine. And as long as you show a passion for solving problems and you have the willingness to teach and learn this material, then that is fine. Obviously, there will be some evaluations later about on your actual capabilities of teaching, but these are just some of the general prerequisites and recommendations for teaching. So key thing is you need a familiarity with AMC 8 and AMC 10, and you need a willingness and passion to actually do it. Oh, sorry. All right, okay, so next up, so for the actual teaching part, what will we be using to teaching? Because this is very problem solving based. So obviously we still need some structure. So we'll be using content slideshows, which are currently still work in progress. And these will cover, so I'm gonna be discussing like what is specifically on these content slideshows later, but it's mainly, there's gonna be content slides, which discusses and reviews the content in brief. This is basically to help review these concepts just in case students forgot. And then next up, right after the content slides, we have some problem slides, which will cover problems related to that concept of varying difficulty, either taken from the AMC's, math counts, and other competitions. And after, we have solution slides, which will cover the solutions to those problems. And once again, to reiterate, it is very problem oriented. So if you are teaching this, then the focus will be on the problems themselves. So concepts are important, but the main thing is you focus on the problems and devote most of the time to the problems. And for actual like explaining things, I highly recommend using the annotate tool. So for example, you have like a whiteboard, and that's where you can show your work. And you can use whatever tools you want for actually drawing stuff on Zoom. So for example, right here, I have this stylus iPad. Basically, it helps me write better, basically. So whatever is fits best for you. And onto the actual curriculum. So now I'm just going to go over in general the curriculum. This training session won't go in depth into the specific concepts. So we're just going to go relatively surface level, just go over some of the examples of what we'll be covering in each lesson. But a later training will be including, like, for example, in-depth discussion of these topics. So AMC 8 curriculum. We'll just be covering AMC 8 this training session. So algebra, special emphasis on algebra. So 5 classes. So the first class will be focusing on operations and linear equations. So this is basically, first is to introduce and create a foundation for later more complex topics. So operations and linear equations. So we have addition, multiplication, subtraction, division. This is obviously a very simple example, but the idea is basically some preliminaries, create that foundation, and then we'll hop into linear equations, so variables and equations. So we'll be introducing those, and we'll be giving some problems on them as well. However, it is assumed that the students already have a familiarity with variables and equations. So it'll be, once again, problem focused. Next up, we have advanced linear equations. So this basically takes the first class and steps it up a notch. And we have manipulation techniques, for example, substitution and elimination, which will all be demonstrated through problem solving. And then we'll also do multivariable linear equations as well, and solving them through problems from past contests. And algebra 3, graphing and functions. So we'll be learning, the students will be learning function mechanics first. So they'll get an understanding of what functions are, a review on functions, and then also go into graphing functions. So this includes slope, intercept, which will all be demonstrated through problems. And we also have special functions too. We'll be looking at problems with exponents, factorials, and square roots as well. And next up, algebra 4 will be quadratics and polynomials. So these are very important for just in general algebra, and especially these contests as well. So we'll be discussing factorization, quadratic formula, and Vieta's formulas, and other strategies and techniques to solve and find out different properties of these quadratics. And going from quadratics, we will also introduce polynomials, which is basically like a step up from quadratics. It's not particularly important to know polynomials with degree greater than 2 on AMC 8. However, it does help that students will find that connection between quadratics and polynomials. And finally, algebra 5. So we have sequences and series. So this will discuss arithmetic and geometric sequences and series. We'll discuss the concepts, and I'll actually have what's it called, a demo course run through relate with the slideshow for sequences and series, so you guys can take a look at what the slide shows and what the content actually looks like. But so yeah, arithmetic and geometric problems, and we also have general sequences in series. So for basically defined sequences in series that don't necessarily fall into the category of arithmetic and geometric. So that's for algebra. That's the general overview of what we'll be covering. Obviously, this can change in the future, but this is the course, like these are basically the content areas which we'll be focusing on. All right. Anyone have any questions? Nope. All right. Okay. Now we move on to word problem. Oh,
can I ask a question about AMC 10? Does that cover algebra 2?
Yes, AMC 10 does cover algebra 2.
Because my friend has not taken that class, but he wants to take AMC 10 in November. So I just don't know to what extent it will cover algebra 2.
So it does cover a lot of the functions, for example, exponents, graphing, functions. However, it's mainly the problem solving aspect. So when will your son be learning algebra 2? Is it high school
Yeah. Oh yeah.
freshman?
So by the way, he's gonna take this summer. He was originally scheduled to take in the fall, but the school allowed some students to take in the summer as a summer course. So by then he will be okay. But I just thought that for other kids, if they don't take algebra 2 in the summer, and does that cover geometry also? Because I know a lot of kids take out geometry in ninth grade.
Yep, this class will cover geometry. So
Okay.
AMC 10 and AMC 8, they're pretty, there's quite a bit of geometry on there. And in this
Mhm.
class, there will be a general run through of like geometry and like how to do problems in geometry. But it would definitely help if you had some familiarity and learn a bit ahead of time on, like, for example, triangles, but it will review those concepts. So for
Okay.
example, AMC, it will go over, as I'll discuss later in slideshows, it will go over like angles, triangles, quadrilaterals, and circles. So
Okay.
yeah, and about algebra
Mhm.
2, it definitely does. However, that's just one aspect, one area of AMC and AMC 10. So it doesn't go too into algebra 2. Mainly it's taking those algebra 1 concepts and applying them to more challenging problems. So it's more problem solving based, meaning you can definitely still do well in AMC 10 without that much familiarity with algebra 2.
I see.
Hopefully that answers the question.
Sure. Yeah. Thank you. Another question
Mhm.
is that the AMC 12 covers pre-calculus?
Yep, that does cover
Okay.
pre-calculus. So AMC
Okay.
12 does do
All of
complex numbers.
pre-calculus. I
Yep,
see.
and no, except not vectors or matrices. It does not cover that, but it does cover doesn't cover polar coordinates. It does cover complex numbers, and actually, I think it does cover polar coordinates. Trigonometry,
Mhm.
logarithms, functions like logarithms,
Mhm.
floor, and also um, complex numbers.
I
So,
see.
yeah. Mhm.
Definitely does not cover, AMC 12 does not cover calculus.
Yep, not at all.
Okay. Thank you so much.
All
Yeah,
right, no
that's
problem.
all. Thank you.
No problem. All right, okay, so word problems, graphs, and table interpretation and logic. So this kind of builds on algebra, but these are more miscellaneous type problems. So we have word problems. So this is where I'll be introduced to ratio, proportion, and percentage, and also rate problems, which are quite common in AMC 8 problems. And there are also graphs and tables on the AMC 8. So we will discuss those in brief. For example, statistics, mean, mode, and median. And finally, some miscellaneous logic. So there are some problems that don't really fit the category. So we will discuss some of those examples in class dedicated to logic and miscellaneous problems. All right. So now on to the number theory. So there'll be 2 classes on number theory. So number theory 1 will just cover integers, basic concepts about integers, and also primes. So prime factorization, and also greatest common divisor and least common multiple, building on primes and factorization. Number theory 2, introduction to modular arithmetic. Not really that important, but just as an introduction, and also divisibility rules like units, digit, and yeah, divisibility rules related to units, digits. All right, so next up we have counting and probability. So this is another 2 classes. Obviously, this can change. For example, you can, if the students are struggling more on counting and probability than number theory, then you can cover these concepts. So for example, counting and addition, multiplication properties, permutation, combination. You can cover that over a span of 3 classes instead. So this is just a general guideline to follow. Obviously, it depends on how the performance and the familiarity with the students have with the concepts. So obviously, you do have to gauge the students' abilities to gauge the students' abilities in certain areas and then adjust accordingly. So for example, counting. So the first class will be dedicated to addition and multiplication properties of counting. So this includes, so yeah, the multiplicative property of counting and relatively simpler examples. And then we'll go over some Venn diagrams and lists. So this does show up quite often sometimes. And also permutations and combinations, which is a little more advanced on the advanced side. So we do go over the context around permutations and combinations. And we will discuss some counting strategies as well. But that also extends into probability and advanced counting. So probability is like an extension of counting. So we'll discuss probability concepts, and then just like what is probability and like how counting relates to probability. And then we'll go into some more advanced counting and probability strategies such as casework and complementary counting, which does show up quite a bit on AMCs. Next up is geometry. So 3 classes on geometry. And the first class is angles and triangles. So we'll first introduce angles, which is parallel lines, perpendicular lines, and angle chasing. And then we'll introduce triangles, basic ideas of triangles, for example, introduction to triangles and relating angles to triangles. And then geometry 2 extends that beyond to polygons as well. So advanced triangles. So we'll cover more other properties of triangles such as area, similarity, and Pythagorean theorem based on what we learned in geometry 1 and polygons 2. So if we have time, if you finish like advanced triangles, then you can move on to polygons as well, talking about quadrilaterals such as squares and parallelograms. And the last geometry class will be focused on circles and other topics if you get the time. Circles, this includes areas, circumferences, and chords, and the center of a circle as well. So problems will be done on these, finding, for example, the area of the intersection of 2 circles, or finding the circumference of a sector of the circle, or like finding the length of a chord in a circle. So these are some example problem types you might find on the AMC 8 and also on the AMC 10 too. But this is just geared towards AMC 8. So yeah, these will be, so that is the core curriculum. Basically, that's basically the outline of all the different topics that will be covered. And next up, we'll move to tips for teaching. So for teaching difficult concepts, it is best to be direct and simple as possible when explaining. Because a lot of times I find that like solutions online can be extremely like complicated, and like I'm just so confused as where they're trying to go. And when the solution can just be explained in much simpler words, like they don't have to go that complicated, which is kind of annoying. So don't be like that. So yeah, don't make things sound more complicated than they actually are. So when you're explaining triangle for the first time, don't be like it is a 3-sided polygon whose angles add up to 180. Just be like it's a 3-sided shape and give an example. And relate difficult concepts to similar and familiar concepts. And going back to the triangle example, a polygon is basically, you can relate, for example, polygons to triangles. This is a rather simple example, but you can be like, triangle is a 3-sided polygon, and a square is 4-sided polygon. So relate difficult concepts to similar and familiar concepts. So the overall goal here is don't confuse the students. Try to keep things as simple as possible. And the way you can do that is by teaching by example. So for example, when you're discussing geometric series, you can use the simple 1 plus 2 plus 4 plus 8 all the way up to some number like 16 as an example. Obviously, I mean, like most people find that when you have an example, you grasp onto the concept much easier. And kind of going along that line of thought, remember that concepts are taught by applying them. They sink in the brain best when you actually apply them to problems. So obviously don't focus on concepts for too long. Try to just move as fast as you possibly can, to the problems. So that way they have some students can get some problem solving experience in that area. For the people who just joined in, I can share the slideshow so that way you guys can take a look at the previous slides. So yeah, moving on to tips for teaching continued. So previously we looked at teaching difficult concepts, and now we want to look at teaching and walking through difficult problems, which oftentimes can be a bit more challenging because everyone has a different thought process for solving problems. So that can be a bit challenging. One of the hardest parts about teaching something like this would be the problem solving part. So what you want to do for teaching difficult problems is you want to go through the thought process and motivation behind the problem. So for example, if there's a problem asking for divisibility, you might think, okay, so that means that it can be a factorization problem. And if it's a factorization problem, then what do we do? And for example, if it's asking for triangles, or for example, there are parallel lines, what does that mean? And one thing that helps is if you can ask guiding questions to help the students get to the solution if they're stuck. Like, if there are perpendicular lines, what does that mean for the angle between those perpendicular lines? And then that might lead to a realization. So that's a relatively simple example. And you want to break the problems into steps. So make the problem more manageable by breaking them into steps. So I know this might be a bit difficult, but there are solutions online to a lot of these problems. So I know it's really hard sometimes to like come up with a solution to every single problem, especially you're teaching a lot of problems and you probably have a lot of classes outside of this as well, and a lot of other commitments. So what you can do is basically take the solution and take just a chunk of it that makes sense, and then just present that, for example, like, okay, so first step is we do this, blah, 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 we factorize, and then blah. So you just take a solution. So I'm going to discuss some resources where you can find problems and solutions on the AMC 8 that will help you out in teaching this. And another thing is to simplify the problem. So that's another tip for teaching a difficult problem, which is to give a simpler example. And you want to relate the problem to more familiar concepts and problems. So for example, if you're doing an accounting problem that has 10 cases, right? Or something that's, for example, like there's a problem with related to people and there's 10 people. So it's quite complicated. Take the problem and just choose 3 people instead and see what happens there. See if you can find a pattern. So basically take a simpler example of the problem. And most importantly, you want to give time for the students to think about the problems on their own, because these challenging problems do take time to understand. So a bulk of the class is actually, I'd say like, I don't know, a third to half of the class is that you should give time for the students to think about the problems, and obviously be there to ask any questions, guiding questions, and answer any questions that the students may have. All right, so we're going to move on to the actual lesson. So we took a look at the overall curriculum. Now we're going to take a look at what happens within each class. So lesson guidelines. So as of now, they're going to be our classes. That can change in the future, but that doesn't really change like what goes on within each class. So the beginning of class will obviously introduce the topic of discussion and give students time to settle, take attendance and all that. That's going to take roughly 5 minutes. And also answer any questions that the students may have about the previous class. After that's done, move on to problem solving. So this includes going through concepts and problems relating to the topic of discussion, and try to go through as many problems as possible, but to an extent, of course, that the students are given plenty of time to think about it and soak in the problem and make sure that they actually understand it. And if you don't get to all problems, make sure you do at least one from each concept. So as you'll see later, when I do go over like the course, like a demo class, I'll show you that there are several problems corresponding to a single concept. So try to do at least one from each concept. And at the end of class, so 5 minutes to answer any questions that the students may have, and also to assign homework, which I'll discuss in a later slideshow. So the general format for each concept. So the class is broken up into different concepts. So we'll discuss several different concepts through the class, all related to the topic. So the general format is we first discuss some theory and important concepts. This is generally as more of a review, and it's kind of assumed that the students already have some understanding and familiarity. And then to give students time to actually solve those problems. And finally, to go over solutions to the problems. All right, so first, discuss theory and important concepts. So these in the slideshows, they'll be blue titled, and they're basically to discuss and review concepts. So a prime is a positive integer whose only positive divisors are 1 and itself. So you have a definition, and now you want to give some examples. So what counts as a prime? So why is 2 a prime? So 2 can only be divided by 1 and itself. And why is 11 a prime? So you can give some examples to help better explain what it is. And then next up, you discuss the second concept, prime factorization of an integer is a product of primes equal to that integer. Take 90 as an example. And a composite. So when you're explaining composite, you might want to give an example such as 6. So 6 has a divisor other than 1 and itself. Why? Because it can be divided by 2 and 3 as well. And then, so when you're discussing this, you want to ask for any clarifications and questions. And very important to gauge the student's familiarity and understanding of the concept, so that way you know the next steps to take. For example, all right, so are we going to give them an easier problem or a more difficult problem? And how much time we can spend on this concept. And then give students time to solve problems. So this should be majority of the time. As you can see, there's problems listed on the slideshow. And problems following the concept slide are directly related to that concept. So primes and composites. These problems are all related to primes and composites. So the problems directly follow the concept. And obviously give time for the students to think about the problem, and do not try to get through all the problems, because if you rush through them, students won't understand any of it. And try to get some from each concept. So for example, if you don't have time to do all these, just do one of them. For example, the first problem over here, let W, X, and Y, and Z be whole numbers. And if the students are struggling on these problems, you can give guiding questions. So for example, if you see an equation where there's primes on one side and a composite on the other, what do? What's the best approach next? And then the students might get to the answer, oh, we can prime factorize 588. And so that's if the students struggle, but you should give some time on their own for independent thinking, uninhibited thinking. Basically, just give them independent time. All right, so next, afterwards, go over solutions to the problems. So it's very important to understand the solution beforehand to the problems you plan on discussing. So that way, if the students throw questions at you, you'll be able to answer them in a very detailed and professional way. So for example, right here, so prime factorization of 588 is 2 squared times 3 times 7 squared. What the student might ask you is, how did you factorize 588? So that's why it's very important to understand the solution and how to get there. So an example response is, well, first we can try something like 2. So let's try to divide different primes into 588 and see which ones actually divide. So let's divide 2, and it divides, and then you continue so on and so forth with the other primes. So yeah, very important that you understand the solution ahead of time, so you seem very professional when you discuss it, and you're very knowledgeable about the solution and the problem. All right, so onto some resources that you prospective teachers can use for this. So art of problem solving is probably the best resource for contest math. And it has basically open access problems and resources for a ton, many competitions, which you can pull from to give to your students. So this includes AMC 8 and AMC 10 problems. They come with the solutions as well. And obviously, this can be useful for both students and teachers. So you can also introduce this platform to your students as well. And there are also some recommended books which you can use and pull problems from, which is AOPS, AOPS, volume 1 and volume 2. And obviously this is not a requirement, but this is just a suggestion. There are also other content-specific books by AOPS as well. Introduction to Counting and Probability. But if you don't want to pay for these books, just settle for the website. That's honestly good enough. It's got everything on there. So it's got a wiki page for different concepts as well. So it's pretty much, it's the best source out there for mathematics, competition mathematics, and resources. All right, okay. Continue resources. So these are other resources you can use. So we have a lesson plan, so the guideline, which I can send out later. So this is basically, it's kind of like what I covered back in the curriculum slideshow, basically the guideline, but it's a bit more specific to the class itself. Like how much time do you want to spend on arithmetic sequences or geometric sequences? So it just has the general timestamp of that. We have lesson slideshows, which are currently work in progress. So yeah, those are basically formatted as in this way that I mentioned when discussing the general format of each concept. So these are kind of like, I'll show you an example slideshow later. So yeah, another thing that's very useful is, this is once again in AOPS, is the AMC problem archives, which is basically has all the problems. And let's actually go to it right now and show you. It has all the problems listed by year, which is very, very handy. So for example, AMC 8 problems and solutions. Let's choose 2019. And it just gives all the problems list here. And let's choose problem 2. And it gives a problem and then several solutions. So this is very, very, very useful for teaching. All right, okay, special classes. So these are classes that don't really follow that general format that I talked about before. And that's the first introductory class and the last classes. So for the first class, you don't want to cover anything like AMC specifically related, like algebra. You don't want to go into that the first class. So you mainly want to introduce yourself and your qualifications and some icebreakers as well. So introduce, let them introduce themselves as well. And their grade and their background in mathematics. And then you want to introduce the course content and guidelines. And then for the remainder of time, it's recommended to dedicate to solving problems, which kind of survey all the topics. So just, for example, from the AOPS resource, you just take a few problems from AMC 8 and just give it to them to solve. And yeah, so it's kind of like used to whet their appetite to AMC, and also to gauge their abilities as well at the same time. And after you finish the introductory and like the core classes, the last few classes, if there's remaining time, that is like you finish teaching the core concepts, then you can go over and review problem solving skills needed for AMC competitions, and also pull problems that are particularly challenging as well. So you want to give them, as the last class, you want to basically review what you kind of learned. So give them a little review and then give them challenging problems that kind of hone those skills. Because, by the end of the class, like they're probably going to forget some stuff back in algebra, back in like the beginning of class. So that's the purpose, is to basically, take it all and basically cement it in their brain. And for AMC 8, the last class, it is recommended that you give them a mock contest for the AMC 8, which obviously you can pull from this resource over here. So give them, and so it takes 40 minutes to do the AMC 8, and the class is an hour. So you'll have time. So for example, 40 minutes, and then you take a look, and then you can grade them and then see, all right, so how well did this student do? Where did the student struggle? And all of that. Okay. On to homework. So make sure that students are getting practice outside of class, because it is a problem solving focused course. So the best way to improve is for students to solve more problems. Very, very important that they solve problems. If they're not solving problems, then it's really hard for them to improve. It's not like school mathematics where if you just know the concepts, or if you just know like the theory and the concepts, then that's basically enough. In this case, it's far from enough. You have to do problems, and specifically difficult problems. And it is recommended to assign the problems that you didn't have time to cover in class for homework. And so yeah, for example, in the slideshow, you didn't get all the problems. So just take those problems and, organize them and send them to your students. Obviously, this is just recommended. You can do whatever you want. For example, you can do something on AOPS related to their homework as well. This is just recommended. Mainly is just give them problems. All right, so some other general tips for teaching. To reiterate, it is a problem solving class. I kind of repeated that like 10 times, but yes, it's very important. And focus on the problem solving aspect. Yep. And in terms of dealing with the unexpected, prepare for the worst. So there might be one student or two students out of the whole class that doesn't understand the material at all. Like for example, you give them geometry, but they didn't really cover geometry. Then what do you do in that situation? Well, obviously, it's a hard situation, but you're probably going to have to continue the class, and then after class, send them information to catch up. So it's a difficult situation, but you want to follow the majority here. You don't want to hold the entire class just for those two students. And there might be one student that's always late. Then you might want to, after class, you might want to explain, why are you always late, and all that. So prepare for the worst. Try to keep everyone on the same page, but that's not possible sometimes. So you need to understand, okay, so let's say some people don't understand and are not on the same page. What do we do in this situation? That you have to prepare ahead of time. And if students are absent, then send over class recordings and supplemental resources, recommended AOPS. And if you are absent, so not the students, then make sure you tell a substitute, or you can reschedule the class, either one. Tell a substitute what the class will be working on and the teaching materials. All right, so an example class walkthrough. So I'm just going to show you, because we are running a bit on time, and I want to give you guys some time to ask any questions that you have. This is an example of a slideshow that you can use for teaching. So you start here, hi, my name is Andrew, this is sequence and series, so this is what we're discussing. And then you go into the concepts, blah, 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 arithmetic sequence, right? You explain it, you explain this formula. Okay, so for arithmetic series, if you want to find the sum, which is Sn, then that's this, and explain what the variables mean. Then you move on to problems. Okay, all right, we're gonna give you like 5-10 minutes to solve this problem. And let me know if you have any questions or you need any guiding hints. And then you move on to the solution. So what is recommended, like I mentioned before, earlier in the presentation, is using the annotate tool on Zoom. This really helps. So here you can draw stuff out. So for example, Sn is equal to A plus D, and such. So this is where you can show your work. And obviously you can reorganize the slideshow or use a whiteboard, so that way you have a lot of room to, write stuff. So obviously you should definitely use the annotate tool, so that way you can show students your work and help explain things in a better way than just verbally explaining them. And then you want to show the students the solution or walk through it yourself, but sometimes it's just best to just show the solution. And then obviously give them some time to think about the solution. So just like give them time to think about the problem, give them time to think about the solution as well. So we have a second problem. Obviously, you don't have to get to it. Obviously, these are all taken from past AMCs, by the way. So just as as a note, these are all problems taken from AMC. So if you don't want to use a slideshow, then what you can do is you can just take problems that you feel are most suitable for the students and will benefit the students from that AOPS resource that I showed you guys earlier, and then just give it to them. Give those problems to them rather than the ones on the slideshow. That's perfectly fine too. All right, so next up we have a second concept. So notice how there's this concept, all these problems related to that concept, and now we have, oops, this is the second concept, and there are more problems related to that. Third concept, more problems related to that. And notice how there's quite a bit of problems, and there's some backup problems. So these, for example, these you can assign as homework. And here's some other backup stuff. And if you basically, when you're preparing, if you find something that it's not that useful, but if you can get to it, that'd be great. Then it'd be something like this. All right. Okay, so that's pretty much it for the slideshow. So that would basically be, you'd spend like 5 minutes on this slideshow explaining what it is, asking any questions, and then 5 minutes at the end, once again, answering any questions that the students might have. All right, so that's pretty much it for the walkthrough and discussing the curriculum and content and such. So now I open the floor to any questions that you guys may have.
I actually have a question. I used to be a grader, and then like, what do you consider like cheating, or what's okay, and can they work with themselves, or like, that's in general what I want to ask.
Oh, okay. So you're worrying about like, are the students going to be, for example, like during the homework, are they going to maintain integrity, and like they're not going to ask their parents for like?
No, it's because when in my class I was grading, I guess somebody made like a Dropbox, and they all like, and I saw the same thing again and again and again and again.
Oh.
And I was just like, I went a little bit, like I started giving people cereals, and it was not good. It was just bad for everybody, I guess. But
so if
just,
they, that's yeah, if that happens,
they probably won't. Just, I guess, just from the start, be like, I want you to be like honest and do your own work.
That's I'm definitely in the beginning stress that it is very problem solving focused. So if you don't do it, you're not going to improve. You're just going to be wasting your parents' time, your own time too, and your money, because a lot of it is problem solving focused. So you can't just walk through expecting like copying someone else's work. That's definitely not going to benefit you at all. Like if you want to do well, assuming you come here to do well on AMC competitions, that's definitely not going to cut it. Like you're not going to improve at all. So I'm going to, and for teachers out there, prospective teachers, make sure you make that clear that you're not going to improve at all if you just basically copy other people's answers, and if you're not being honest with yourself, you're not going to have a high score, basically. Does that answer your question?
Yeah, that's a good speech.
All right. Okay. All right. Any other questions? This can be about like what's the next steps, and what's like the status, and like any other more in-depth details into what this is about. Because obviously there's a lot of uncertainty right now, because this is the first time that we've done anything like this. So obviously there's a lot of things that's susceptible to change. Obviously nothing is perfect right now, so a lot of things are susceptible to change, and obviously things have sometimes and will inevitably have to be moved around and such. So for example, this slideshow might need further editing. Like these problems might not be the best problems. So yeah, that's very important. So yeah, any other questions?
I have a question.
Mm-hmm.
Wasn't there was supposed to be a Scratch junior coding workshop today?
Oh yeah, that might be right after this. Let me just double check. Let me just see. I do have a list. Yeah, that's oh yeah, that's Scratch junior class. That's from 2 to 3. So that's in like 1 or 2 minutes. So that's gonna be happening in 1 or 2 minutes. Yeah, so this is for Math AMC 8.
Okay, I was just confused. Sorry.
That's all right.
Thanks.
All right, one more minute. Open the floor. Any questions? Oh yeah, if you haven't done so, please fill out, if you're interested in teaching, fill out the AMC course interest form. I believe it's on the Discord server, teaching/TA and IGO Learning new teacher cert. I'm just gonna send it to you in the chat.
For this, are you looking for any TAs? I don't have any mathematics competition experience, but I've taken math in college and school and would love to be around a math community.
Of course. Yes. We will definitely be needing TAs. Yes.
Yeah.
College education in mathematics, I believe that's definitely enough for you to have the qualifications to actually teach a class. So after TA for a while and having like an understanding of what the course is about, then you can move on to actually teaching. Yes.
Okay.
Yeah, we will be needing TAs and like.
Thank you. All right. So just should I fill out the form and specify I'm down to volunteer?
Let me just send it in the chat. Hopefully that works. So this is if you want to teach and you are interested. It doesn't matter don't worry about qualifications and experience, because you can always be a TA. So, and then once you're a TA, you can move on to teaching. So yeah, just like 1 or 2 more minutes, and then I'm gonna close it off for Scratch 000 Junior. And actually, I'll go ahead and send the training info slideshow for those of you who want it. I think that'd be very useful. If you weren't there for the whole meeting, then I think it would be very beneficial if you guys had this. So let me send the training slideshow in the chat for you guys to take a look at if you were a latecomer. And as always, if you have any questions after this, then please feel free to ask IGO Learning about this. Or if you have Discord, then DM me on Discord with any questions. Maybe I should send my Discord information too. Yeah, I'll send my Discord information. Oops, looks like I've been signed out. All right, just one more second, and this is my Discord information for those who want to quickly copy that down. And yeah, so that basically concludes the training info session. Hopefully you learned something about the course and what we're trying to do with math in the future. So yeah, hopefully you guys had an understanding of what the goal is, the content, the curriculum, and what is asked of you guys to actually teach. Like, what are some tips? What are some resources that you guys have at your disposal to use? And also, what are your responsibilities as teachers? So if you guys don't have any more questions, I'll go ahead and close it off right now. Hope you guys have a wonderful rest of your day. All right. See ya.